Hey everyone, welcome back. This lesson is going to focus on what we call sector area and arc length. And basically what we're doing is we're taking a circle and we're cutting it into a piece or pieces and finding the area of each of those little pieces. So kind of like slicing it into slices of pizza, if you would. If you think of it that way, it might help you understand it a little bit. So let's go ahead and get started. Remember, take notes like you normally would. Get your essential question down and your title down and all that. And let's go ahead and get started. Remember, the area of a circle. The area of a circle is pi r squared. And then on top of that, the circumference of a circle was 2 pi r. I didn't write that down here, but those are the two formulas we're going to want to remember for this lesson and for this unit on circles. So the area of a circle is pi r squared. Remember, we know that because the area has units squared, and so there's the squared. And then the circumference is 2 pi r. A sector is like a slice of pizza. The technical definition is the region bounded by two radii and their intercepted arc. So there's my big slice of pizza. And what are we saying here? We're saying that the purple region is a sector. It is bounded, which means it's contained by, it's within, the region is within the two radii, or the radius here and the radius there, and then the intercepted arc. In other words, the radii hit the circle at this point and at this point. And so this length here is called the intercepted arc, if I could trace that a little bit better. So that is a sector. It's a slice of pizza where that pizza is exactly cut perfectly because it's cut through the center. The arc length is the distance between 2 points along a circle, okay? Or along the circumference of a circle. So you can see here, I kind of highlighted it here. The arc length is the distance from one point to another point along the circumference of a circle. So you can kind of make the comparison here. It's one of those analogies, if you would. A sector is to area, or the sector area is to area, as arc length is to circumference. So we're talking about the area of the piece of the circle, and we're talking about the distance of the piece of the circumference. So you can see that this is a certain amount of the whole circle, and this is a certain distance of the whole circle. So those are the two definitions we want to focus on today: sector area and arc length. Well, before we get into actually solving sector area and arc length, there's one more thing we need to know, and that's how to find the portion of a circle. And it's pretty straightforward. If you go to a pizza place and you order a large pizza, most large pizzas are cut into 8 slices. And so if you want to figure out how much of the pizza you ate, well, you would count up how many slices you eat, and you would divide that by the total amount of slices that there are. So if there's 8 slices and you ate 3 of them, then you ate 3/8. If there were 12 slices and you ate 6 of them, then you ate 6/12, or you ate 1/2, because you can reduce the 6/12. So that's basically what we're going to be doing here. A portion of a circle is just the ratio that compares a part of a circle's area or circumference to the whole area or circumference. And so, like I said, it's just going to be a fraction. It's going to be, oh, it's 3/8 of the whole thing, or it's 2/5 of the whole thing, or it's 1/3 of the whole thing. Okay, so let's take a look at this. It's pretty straightforward. What is the ratio between arc AB and the whole circle? Well, arc AB is this arc here. Okay, so what is the ratio between this arc and the whole circle? Well, you notice that we have this little degree measurement here. If you remember, a whole circle, to go all the way around, if you were to stand at the center and face A, and then turn all the way around until you're back to pointing at A again, to looking at A again, you would have gone a total of 360 degrees. You would have turned 360 degrees. Well, what this is saying is if you look at A and then you start turning to look around to point B, you have turned your body 144 degrees. So the portion that we've turned 144 degrees out of a total of 360 degrees. So that's the portion of your circle. That's it. Now, if you want, and you should, you can reduce this fraction by finding a common denominator. In this case, I divided both the top and the bottom by 12, so I got 12 over 30, and then that can reduce even more. If I divide that by 6, I would get 2/5. So this arc AB is exactly 2 out of 5 of the whole thing, or 2/5 of the whole thing. Go ahead and do a practice problem here. So what I want you to do is pause the video and come up with this portion. Actually, this one's probably a little bit more difficult. So go ahead and pause the video. Come up with this portion. We're looking for the ratio that LM is. To the whole circle. And then push play when you think you have it, or just push play to find out what the answer is. All right, for the ratio between arc LM and the whole circle. Well, what I notice here is arc LM is here. There's a couple ways of looking at this. The first thing I know is that this is an equilateral triangle. And so this equilateral triangle is essentially cutting this circle, or cutting the circle into 3 equal pieces, because these are all the same. So if I take 360 and I divide it into 3 equal pieces, I would end up with 120 degrees for each of those pieces. Okay? If I'm looking at it from the center out, so if I start at point L and I rotate around till I look at point M, I've rotated 120 degrees. Well, that would be 120 out of 360, which reduces to 1/3. So the answer is 1/3 of the circle. That should have been pretty easy. I mean, we're cutting this triangle into, or this triangle is 3 equal sides, therefore we're cutting the circle into 3 equal pieces, so each piece would be 1/3. All right, let's go ahead and move on to an example of what sector area and arc length look like. And I'm going to list a number of steps here in the following slide, but let's do an example of this first so you can see what it looks like. It says that the central angle of circle O is 135 degrees. When I say circle O, what I mean is that O is the center. The central angle is 135 degrees. Okay? Its radius is 4 centimeters, so I have the radius. Part A says, what is the portion of the circle? Well, we just did that. The portion of the circle is 135 out of 360, or that reduces to 3/8 if you were to reduce it. Okay. For part B, it says, what is the area of the shaded sector? So we're trying to figure out the area of this green piece. Well, I don't know how to do that yet. But I do know how to find the area of the whole circle. So you see the word area? Well, let's find the area of the whole circle. What's the area of a circle? The area is pi r squared. So since the radius is 4, we plug that in, we end up with 16 pi. So that's the area of the whole thing. Now, how much of the circle do I have? I have 3/8 of this. And now I want to relate this back to one of our very first units of the year when we talked about similarity. When we talked about similarity, we set up proportions. In other words, we set 2 fractions equal to each other, and then we cross multiplied. So I want to use the same idea here so that we're not doing anything new. We're just using the same concept in a different context. So what I'm going to do is I'm going to set up a proportion between the part that I want and the whole thing. Well, what's the part that I want? The part that I want is represented by 3, and the whole thing is represented by 8. So the proportion that I'm going to use is 3/8 equals, so again, the top represents the part, and the 8 represents the whole. So the piece versus the entire thing. Well, we are looking for the area of the shaded sector. Is that the whole circle, or is that part of the circle? That is the part of the circle. So the thing that I'm looking for goes on top. So we're gonna use a variable a to represent that area because we don't know it. And the whole thing, the area of the whole thing goes on the bottom, and we just figured out the area of the whole thing. It's 16 pi. Maybe I should go ahead and write this down so that we can see it a little bit better. You're always going to set up the proportion to be part over whole. Okay, if you can remember that, you'll probably do okay. So the 3/8, the 3 is the part, the 8 is the whole. It's the piece versus the entire thing. The thing I'm looking for is the part of the circle. It's only the portion, it's only the piece. The sector is only a part of the circle, so we have a variable there because I don't know what it is, and then the area of the whole thing is 16 pi. From here, we're just going to cross multiply, so we get 3 times 16 pi, which is 48 pi, and then 8 times a is 8a, and we'll divide by 8, and we end up with 6 pi. Remember, the units on this are going to be centimeters squared. And then if you multiply that out, you would, multiply 6 times 3.14, you would put it in decimal form. All right, for part C, it's going to be the very same thing, except for one difference. Here, we are looking for the length of arc RQ. So we're looking for the distance from R to Q along the edge of the circle, if you would. The length of RQ, well, what is the length related to? Remember, the length, if I'm thinking about part, this is the part of the circle that I want. The whole thing is going to be the distance around the circle. What do we call the distance around an object? It's the perimeter. Remember, the circle has a very special word for perimeter. It's the circumference. So the first thing I'm going to do is find the circumference of the circle. The circumference is 2 pi r, and then I'll plug in my radius, and I end up with 8 pi as my circumference. So 8 pi represents the entire distance around the circle. So from here, I'm going to set up my proportion just like I did before, part over whole. Well, this fraction represents the part over the whole, so it's going to be 3/8 on the one side, and on the other side, instead of using A for area, I'm going to use L for length, or maybe you can write it out, you can say arc length, okay, over, well, what is the whole length? What is the entire length? The entire length is the circumference, so we would put 8 pi down on the bottom. And then we cross multiply from there. 3 times 8 pi is 24 pi, and then 8 times the arc length is 8 times the arc length. We'll divide by 8, and so we end up with 3 pi. And so our units on that would just be centimeters, because we're talking about a distance from one point to another. So that's the example that I wanted to walk you through. Let's go ahead and take a look at a list of steps so that we can make sure that we have this right, okay? And then we'll do some more practice problems here. It's in order to find the arc length or the sector area, the first step, step 1, is to determine the portion of the circle. So that's figuring out the degrees that you have over the entire thing. So the entire thing is 360. Step 2 is to figure out whether you have figure out the area or the circumference, and you got to figure out which one you need depending on what it's asking for. If it's asking for the arc length, you'll use circumference, and if it's asking for sector area, then obviously you'll use the area. Step 3 is you're going to create a proportion. So that means you're going to set up two fractions that are equal to each other. The first fraction is going to be the portion that you had, and the second fraction is either going to be related to the area or the circumference. Remember, it's always the part over the whole. And then from there, you would just cross multiply and solve. Let's go ahead and take a look at another problem to make sure we're good with this. The central angle of circle C is 65 degrees. Its diameter is 24 inches. What is the area of the shaded sector and the length of arc XY? So in this question, we are actually looking for both the sector area and the arc length. So the first thing we have to do is figure out the portion. The portion is going to be 65 over 360, 65 degrees over 360 degrees. And if we want, we can reduce that. You actually don't need to reduce it if you have a calculator handy, okay? But that reduces to 13 over 72. The next thing we need to do is figure out the area or the circumference. In this case, we're going to need both. So the area is pi r squared. Okay, kind of skipped a step there. We need the area. So area is pi r squared. It says that the diameter is 24. That implies that the radius is 12. So when I plug it into pi r squared, I would get pi times 12 squared, which is 144 pi. This is my proportion. So this is the portion that I had here, and then the A represents the sector area, and then the 144 pi is the area of the entire thing. Remember, part over whole. From here we can cross multiply and then divide, but we would end up with 26 pi inches squared. Remember, if it says to round to the nearest tenth or hundredth or thousandth, you're going to want to multiply that out. 26 times 3.14159, blah, blah, blah. If it says leave it in terms of pi, then this would be your answer. All right, for arc length, it's going to be the same exact process. You're going to take the portion, which is 13 over 72, and we're going to set it equal to, the other ratio. Well, the other ratio is dealing with circumference. Well, the circumference of the circle is 2 times pi times r, or in this case, 2 times pi times 12, because the diameter is 24, the radius will be 12. So we would say L over 24 pi, cross multiply, and then divide, and we'd end up with 13 pi over 3 inches, or if you multiply it out, you'll get some decimal value. So that's an example of how to find area, sector area and arc length. Let's go ahead and take a look at two very specific problems pertaining to your questions today. Today's questions are only focusing on arc length. The next lesson will focus on sector area a little bit more. So these questions are just like what you're going to see today in the practice. In both of these questions, we're looking for the arc length of the bolded arc. So what we want to do is set up the portion. The portion is going to be 125 out of 360. We can reduce that if we want, but we don't need to. The step 2 is to figure out the circumference. Because we're looking for arc length, we're going to use the circumference formula. So circumference is 2 pi r. The radius in this case is 13, so that would just be 2 times pi times 13, which is 26 pi. From here, we're going to set up our proportion. It's going to be 125 over 360 equals the arc length over the entire length, the circumference. Cross multiply from here, you end up with something really big, 3,250 pi equals 360 L. We'll divide by 360. And we end up with 9.028 pi, and then if we multiply that out, we end up with 28.362 inches, okay, because I multiplied by the 3.14. For number 2, it's going to be the same exact thing. The bolded arc is the blue one here, so the degree measurement on that is 220 degrees out of 360. The circumference is going to be 2 times pi times 11, so 22 pi. And then setting up the proportion, we've got 220 over 360 equals, well, what is the part? The part is the thing I'm looking for, the arc length. And then the whole is going to be the entire circumference, so over 22 pi. We'll cross multiply there, 4,840 pi, and then equals 360 L. Divide by the 360, and you end up with 13.444 pi. Or if I multiply that out, I get 42.237 feet. All right, that wraps up the lesson for today. I want you to continue on in this assignment, answer the questions that are below. If you have any questions, make sure you log into the Zoom office hours so I can help you out. But otherwise, I will see you around next time.